Have you ever looked at a device and wondered how a single tiny light can glow in literally any color of the rainbow? Well, it's not magic, and today we're going to pull back the curtain and see exactly how it works. We'll be taking control of a multicolor LED using a super simple computer called an Arduino, and trust me, it's way easier than you think.
So that's the big question, right? How can one little light create millions of different colors? The secret isn't really about one light. It's about cleverly mixing a few basic colors together. Let's meet the little component that makes it all possible. The hero of our story is the RGB LED. And the name kind of gives it all away. RGB stands for red, green, and blue. See, inside this one little package, there are actually 3 separate tiny LEDs. By controlling how bright each of those 3 colors is, we can trick our eyes into seeing any color we want. Okay, let's get our hands dirty and start connecting the physical parts. Now, if you're new to this, a diagram with a bunch of wires might look a little intimidating. But don't worry, it's really just plugging a few things in. We're going to walk through it one step at a time. Here's the big picture. This is our finished circuit, our end goal. You can see the Arduino board, that's our little computer. There's our RGB LED, and a few wires to connect everything together. Looks simple enough, right? Now, let's build it. The connections are super straightforward. Each of our colors gets its own special control pin on the Arduino. So, the red pin goes to pin 11, the green pin goes to 10, and the blue pin connects to 9. That 4th pin, the longest one, is our ground. We just connect that to any of the G&D ports and boom, the hardware is all set. See? That was easy. All right, our circuit is all wired up, but right now it's just sitting there. It needs instructions, and that's where the code comes in. This is the brains of the operation, where we tell the Arduino exactly what we want it to do with that LED. This is how we bring it all to life. So every Arduino program, or sketch as they're called, has 2 main parts. The first one is setup. Just like the name says, this part runs only one time, right when you power the board on. Think of it like a preparation checklist. It gets everything configured and ready to go before the main program starts. So what's our setup checklist doing here? It's really simple. We're just telling the Arduino that pins 11, 10, and 9 are all going to be used as outputs. That means they're going to be sending signals out to control our LED. We're basically saying, hey, pin 11, you're in charge of red. Pin 10, you've got green. And pin 9, you handle blue. Easy as that. Now for the second part, the loop function. And again, the name says it all. This is the main event. Whatever code we put in here will run over and over and over again forever as long as the Arduino has power. This is where all the color-changing action is going to happen. This is it. This is where everything we've done comes together. Let's step through the code inside that loop and see exactly how we command the Arduino to create our awesome sequence of colors. The very first thing our code does inside that repeating loop is tell the LED to turn pure red. So, how does it actually do that? The magic command here is analog right. This lets us control the brightness of each color. Think of it like a dimmer switch that goes from 0, which is completely off, all the way up to 255, which is full blast. So to get pure red, we tell the red pin, pin 11, to go to 255, and we set green and blue to 0. Next up in our sequence, the code creates yellow. But wait a second, we have a red, a green, and a blue light. We don't have a yellow one. So how in the world is this possible? And this is just plain cool. It's all because of something called additive color mixing. With light, it's different than paint. When you mix red light and green light, your brain sees yellow. So the code just tells the Arduino, hey, turn the red pin and the green pin to max brightness, 255, while keeping the blue one off. And just like that, we get yellow. The last step in our repeating cycle is to create a nice, pure, vibrant blue. You can probably guess how this works by now, right? To get pure blue, the code just does the opposite of what it did for red. It turns the red and green pins completely off by setting them to 0, and cranks the blue pin all the way up to its maximum brightness of 255. Now, if the code just ran through all those color changes as fast as it could, it would all just be a blur. That's why you see this delay 1000 command in there. This literally just tells the Arduino to pause and do nothing for 1000 milliseconds, which is exactly 1 second, before it moves on. This little pause gives our eyes a chance to actually see each distinct color. And that is the whole secret right there. It's a really simple but incredibly powerful formula.
You connect the hardware, the physical parts, and then you write code to tell that hardware exactly what to do. That beautiful combination is what gives you total control over light and color. So the biggest takeaway, the real aha moment here, is that by controlling the individual brightness of the red, green, and blue lights, you can create pretty much any color you can imagine. Want purple? Turn up red and blue. Want white? Turn all three on full blast. You have a palette of millions of colors, all just by changing those numbers between 0 and 255 in your code. So there you have it. You now have the fundamental building blocks to control light and color. You could make a pulsing mood light, a custom notification light for your computer. You could even animate a whole rainbow fade. The only thing limiting you now is your own imagination. So, now that you know the basics, what will you create?